Okay, so this is going to be the data video. And so we're going to start exploring part one. Now, I've opened up my simulation here as inside of this Flash player. I actually had to download the SWF file, and then I opened it with my Adobe Flash. Right? Now, if you don't know how to do that, that's fine. We are going to collect all the data you need inside this video. But if you do want to do that and you want to play around with it, then I totally encourage you to go for it. All right, so first we're going to select our solvent. So in this case, we're looking at water. All right. Now we also want to select our solute. Our solute is going to be the sodium chloride. And so this first one, we're going to go ahead and put 0 grams in. Now we will want to boil water, so we're going to leave this as the hot one. You can start that out. Mixes in, starts to heat up. We're just waiting to see when will that come to a boil. Looks like it came to a boil at 100 degrees. Perfect. Kind of what we're expecting. So we're going to reset this one. We're going to go ahead and this time we're going to add in 5 grams. Still on hot, still with the water. That's 100 grams of water. All right. So we definitely got up a little bit past that 100. So 100.85 was kind of what I saw. Okay, we're going to reset it. We're going to try it again, but this time we're going to go up to 10 grams. Now, while it's boiling, you want to make sure that you try to get your highest temperature that you see. So make sure you take your time. Don't jump in there too soon. Think that it's boiled at 67 degrees. It's going to be a little bit tricky. So I'm trying to make sure I give it enough time, make sure it really reacts in there. All right, so I saw 101.60. Looking at our next one. So now they want us to explore kind of the freezing point of the water. And so this time when we reset it, we're going to go back to the 0 grams, like there's nothing in it. And I'm going to switch my hot bath to a cold bath. So now instead of boiling my solution, I'm going to be freezing it. So as you can see, because it's a cold bath, our temperature is starting to go down and down. All right. So you can put this down as negative 0.02, or I'm just going to put that as 0.00 because it doesn't have anything inside. Looking at the reset of this, you can bring this up to 5 grams. Mix that on in there. Waiting for it to freeze. You can see that the simulation has the solid starting to get it to freeze down here at the bottom. So it looks like I saw negative 3.04. We're going to try that same thing, but we're going to do it with 10 grams. Let's crank that up. See, it's starting to freeze right there. It looks like negative 5.78. Okay, and so that's kind of like our introduction. So we've done like our freezing points for a couple. We've done our boiling points for a couple. So then we would try to answer this information. Now, because we've already done them, then For this top part, I don't necessarily need to rerun these. I can just pull that data that I had collected back down here. So that was the boiling point and the freezing point with no NaCl. And then I can pull it for 10 grams as well. And so I'm going to use this 101.60 minus 5.78. So 101.60 negative 5.78. So now I have my freezing point and my boiling point for them. And so now it's asking us for that difference in temperature. That's going to be our delta TB, right? So this becomes a positive 1.60, and this becomes a negative 5.78. Now we're going to try that simulation again, but this time we're going to collect it for our CCl4. So I'm going to change that to carbon tetrachloride, and I'm not going to have, I'm still doing sodium chloride, but none of it in. Oh, sorry. We got to reset this. I had to make sure that it was on the hot side, so we're doing the boiling point. It's starting to heat up here. Right there, that's 76.5, 76.52. Okay. Now I'm going to add in my 10 grams. Mix that in there. Oh, definitely a big change there. 92.15, 16. Can you reset that? Let's change that to cold. 0 grams. Go ahead and start that off. Negative 23.01. Reset that, crank this up to the 10 grams. Freeze this one now. Oh, you really jumped down there quick. All right, see this is negative 116.03. Oh, not 03, sorry, 0.32. And so now you can calculate your own delta T's. I'm going to reset this. We're going to now look again at another solvent. So that was carbon tetrachloride. We're going to look at another one. We're going to look at ethyl ether. So ethyl ether with nothing in it first. Oh, I forgot to change that to my boiling. So ethyl ether, nothing in it. Boiling point right there, 34.50. Maybe 5.2. We'll reset that. We'll crank that up to 10 grams. I'm going to go ahead and update this. All right, we got that mixing and boiling. All right, looks like we've kind of hit it. 40.54. Reset this, change it to freezing, change it down to 0 grams, start it again. And put this as negative 116.22. Going back, reset this, crank it up to 10 grams. Go ahead and mix that inside. So we've definitely gone lower, negative 121.77. So now that our table is done, we want to go ahead and calculate those delta T's. And then we want to try to see how they compare with these other ones. So now that we have that done, you want to make sure you answer these questions about part 2 and see what you kind of notice with the data. Now, these trends might not be true of all solvents and all solutions, but this is just us starting to build some thoughts based on the couple pieces of data that we've collected. Our next part is part 3, and we're going to explore kind of the impact of multiple solutes. Now we're going to change what we're dissolving inside. And so we're going to keep our solvent as water in all of these cases. We're going to explore the sodium chloride, calcium chloride, and sucrose. So we already know our sodium chloride one, right? When there was none inside, our boiling point was 100.00. When 10 grams was inside, I can go back up here, 101.60. You can also rerun the experiment, doesn't hurt. And now we can do our calcium chloride. So on this calcium chloride, so I need to change that to water. I want to change this now into calcium chloride. Now my boiling point is still going to be the same, still 100.00. Since that's not going to be impacted, since this is the one with 0 grams of the solute dissolved inside. But let's see if with 10 grams, does it change something for our boiling point? Looks like we're coming to a stop here at 101.25. Going to our sucrose now. So let's make that clear. Going to our sucrose, we can reset this, change that to sucrose, put in the 10 grams. Looks like it's stopping at this 100.13. Lucky now where you want the freezing point of our water, so we knew that it froze at 0.00. We had the 10 grams of the solute inside, and that was the negative 5.78. And so looking at our calcium chloride now, change that over to our freezing. All right, it looks like it froze. We can put that as that negative 4.58, which was the lowest we saw. Going back to our sucrose now, reset this, put in some sucrose. Sucrose is also another name for sugar. It's a type of sugar. Go ahead and freeze those up. And so the lowest I saw was minus 0.51. So now we've collected our data. So for these next couple points, you want to find those delta T's. Once you know that, you can also start to find the molar mass. Now remember that this is the molar mass of the solute. And the reason why I want that is because we want to try to find the moles of the solute. So we're trying to figure out how much solute we're putting in because we are trying to get to this molality here. So if we know the moles of the solute, we should be able to figure out the kilograms of the solvent we put inside, and we can kind of go from there. Now, the Vat Half Factor, this is the number of particles formed when that solute dissolves in water. And so if we think about it, we're using NaCl. Now, NaCl, it is an ionic compound, and it is a strong electrolyte. So when it dissolves, we are expected to dissociate into Na plus and Cl minus. Now, what this accounts for is while we only put in one of these, we are getting two particles out when it dissolves. And so that's what the Vat Half Factor does, is it helps us adjust for the fact that this one did not stay together. Now remember, not all materials disassociate when we dissolve them inside of the water. So you want to pay attention to that when you make these adjustments. And so as an example, this one would be my 2. And so now my adjusted molality would be whatever I had in box I times whatever I have in box J. And that should give it to me. And then at the very end, we're going to find our KB, which is kind of like the boiling point depression constant. And so each solvent can have a different KB. And so we're going to see how ours lines up for this one. And so you can go ahead and recalculate that based on taking whatever we had for C and dividing it by whatever we have in K. So you're going to find the KB for that one. You're going to find the KF, and then you're going to answer some questions about this. Now, you can play around with this. There are some more different compounds that you can kind of mix as well. You do need a flash player. That is the one part. So I will link to the simulation, and if you want to try to do this yourself, you're more than welcome to do that. If you want to see what the micro level reaction they're talking about, you can kind of see it here. You can kind of see our solute particles are kind of the ones in the orange, and they're kind of getting in the way as they kind of go through that process. If we do it on the other side, you can see kind of what the role the orange ones are doing in working with the blue particles, which is our solvent. Okay, good luck.